That's Physics Paper 1, Multiple Choice 2020. Let's get to question 1. Which instrument below can be used, can accurately measure the length of 0.023 meters? Vernier calipers, because when you convert this value to millimeters, you're going to have 23 millimeters. Therefore, 23.0 millimeters. So the one that can measure, the instrument here that can measure to that degree of accuracy is the vernier calipers. Okay, so D is my answer. Number 2, what is the name given? What is the name and value of the unit of current written as milliamp? MP, that's B, milliamp. I was almost getting confused because both of these made sense. So I had not seen this thing, but the answer is B there. Number 3, 10 identical steel balls, each of mass 27, were immersed in a measuring cylinder containing 20 cubic centimeters of water. If the water level rose to 50, what was the density of the steel? Therefore, mass over volume is density. If there are 10, then each one is 27, then it will be 10 times 27 to the total mass. Volume difference after they have been immersed in water is 50 minus 20, which is 30. The answer comes out as 9.0 B. Number 4, Elena was given a beaker containing 1,000 cubic centimeters of mercury. Given that the density of mercury is 13.6 grams per cubic centimeter, what was the mass of the mercury? Use the formula for density. Mass rho V. So density times 1000, because it's in cubic centimeters and this is also in grams cubic centimeters. When you multiply, it's going to be 13,600 grams was the mass of this mercury. The answer is D. Number 5, which combination below shows the vector and scalar quantities? Okay, you really have to look hard here. Work has no direction. Work is just a scalar. Current has direction and magnitude. Current has direction and magnitude. Power has no direction but it has got magnitude. My answer was B. The diagram below shows a resultant vector of magnitude 6.4 newtons in direction shown. Which diagram shows the components of the vector above? My answer was A. Okay, head to tail kind of vector addition. Okay, so my answer is A, because remember vectors have direction. So if it's facing in this direction, it will fit here. It cannot be here, okay, unless if it was in that direction, pointing from this point to this point, yes, but direction matters. So my answer is A. Question 7. Elena drops a table tennis ball in air. What happens to the velocity of the What happens to the velocity and the acceleration of the ball during the first few seconds after being released? Velocity and acceleration. Excuse me. Velocity increases because acceleration remains same. Constant acceleration means constant increase in velocity. My answer there was C. Number 8. A car starting from rest travels 45 meters in 44 seconds. What is the car's acceleration and velocity at this time? To use this formula here to simply initial velocity, then I make acceleration the subject. The moment before I even make acceleration the subject, remember from rest, meaning this quantity here is 0. Therefore, you are only having x is equals to half at squared. So when you make s the subject, this is what you get, and that's your answer. As you carry on to calculate for velocity, do not round off this part because it has been included here. But even then, do not just round off easily because you can easily go to 6. Okay, so accuracy. My answer, when I simply use this formula for acceleration, the velocity comes out as 22.5. Therefore, my most accurate answer here is B. Okay, 8, the answer is B. Number 9, the diagram below shows a uniform metal bar AB on a goalpost of length 10 meters and weight 100 newtons. What is the upward force? What is the upward force at B? Midway, that's where the center of mass is acting and center of weight is acting. Therefore, B will only experience half the weight of this because the other half is being supported by point A. So 50 newtons is the upward force at B. Question 10. A body of mass 25 kgs was pulled across a level ground with horizontal force of 60 newtons. If the constant friction force is 20 newtons, what is the acceleration of the body? Therefore, acceleration is only caused by the unbalanced force. So I need to find the resultant force, my FR. Action force, friction force, resultant force. Therefore, resultant force is equals to action force minus friction force. The friction force is the opposing force, so it's negative. That's why it's a minus here. The resultant force is 40. The resultant force is also known as the unbalanced force, or the force that brings about acceleration. Then I apply Newton's third law of motion, simply make acceleration my subject, then the answer comes out as 1.6, which is a B. Number 11, the diagram shows a battery operated motor lifting a block of wood at constant speed. Battery, motor, block of wood. What is the overall energy change taking place? A battery has chemical energy. Then this chemical energy is converted to electrical energy, and the electrical energy is converted into some kind of rotation, which is mechanical energy. So my answer here is C, mechanical energy. Excuse me. Number 12, the diagram below shows a load being pulled along an inclined plane. You can see the length of the plane is 5 newtons, the height is 3 newtons. What is the gravitational potential energy and the work done against gravity? Against friction, therefore along this line here, the work done along this line here. So gravitational potential energy is GPE, mgh. Mg is weight, therefore the weight given on the diagram there is a 500, and the height of the ramp is 3. It comes out as 1500 joules. Okay, you can tell already that's this answer here. So going forward, work done along the plane, along the inclined plane against friction. 400 is the force that is being applied to push the box or the load, and then it's covering 5 meters. So multiply these two, force times the distance in the direction of force. It gives you 2000. So my answer comes out as B for number 12. I move the paper. Number 13, which formula gives the efficiency of an energy conversion? The efficiency of an energy conversion, my answer was C. Efficiency is equals to energy output over energy input. Okay, that's that. 14, a gas is trapped inside the cylinder by a movable piston. The length of the gas column is 50 centimeters and the pressure inside the cylinder is P. The piston is pushed in a distance of 30 centimeters, so that the length of the gas column is now 20 centimeters. The temperature of the gas does not change. Temperature is kept constant. This is more like Boyle's law. So here, do not suffer to simply check what the volume of this cylinder is, its diameter, and all those things. Use abstract units. Okay, abstract units. Abstract way of calculating. Therefore, volume and pressure before, volume and pressure after. Therefore, volume was 50, not really volume, okay, I've said abstract. So this will represent some kind of volume. This will be my pressure P. And this is the new volume, and then my pressure X. I didn't want to put P1. Okay, I could have put P1, it's still okay. Still okay. So at the end of it all, when you do your math there, your algebra, the answer will come out as 50 over 22 will give you 2.5 P will be the new pressure. So once we're given this pressure, then yeah, the answer is A. I'm sure you'll see what I mean. Number 15, which statement is correct when a liquid is heated? The molecules expand. What? This is very wrong. Oh yeah, it's incorrect. Which statement is incorrect? Yes. yeah, they don't expand, man, but they do. Everything here is correct. Number 16, a metal lid is fit on a glass jar. What process makes it easy to remove the lid from the metal? Warm the lid only so that when it expands, space will be created and it will be easy to remove. 17, a block of metal has a mass of 2 kg. You mark that one. A specific capacity of 800 joules per kg Celsius. The block is supplied with 2400 joules of energy. What is the rise in temperature? Use this formula here for specific heat capacity. Specific heat capacity is equal to energy over mass multiplied by change in temperature. Therefore, change in temperature is equal to heat over MC, mass times specific heat. My answer comes out as 1.5 degrees. Okay, the unit for temperature is Kelvin, but we're talking about change, so the difference is not really that much, so even this still suffices. The diagram below shows a variation in displacement of a wave with time at a particular point along the wave. Okay, so what is the frequency of the wave? Don't be tempted to count all the way. You and me here can tell to say these are 3 waves. 1, 2, 3. So when calculating for frequency, don't suffer from estimating what time it is. Time is here and it's given here as 2.5. So count the waves that were created in 2.5 seconds. Okay, so the frequency here comes out as when you divide this, it gives you 0.800 Hz or 0.8 Hz. Answer is B for 18. 19. In a petrol engine, which stroke is third in order? The first one is intake, the second one is compression, the third one is power. D is the answer. The fourth one is exhaust. 20. Heat energy is supplied at the same rate to 100 grams of paraffin and to 100 grams of water, in similar containers. Okay. Heat energy is supplied at the same rate of 100 grams to 100 grams of paraffin and 200 grams of water in similar containers. Why does the temperature of the paraffin rise faster? Paraffin has a smaller specific heat capacity. That's true. B is the answer for 20. 21. What is the definition of heat capacity? Heat capacity, they've just said heat capacity, not specific. The moment they say specific, then there has to be an aspect of specifying per kg. It's like defining the Newton. Okay, a force required to accelerate a mass of 1 kg, you're specifying. So when they just say heat capacity, the answer is A. Amount of heat required to raise the temperature of an object through 1 degree or 1 Kelvin if you like. So the answer is A. 22. The diagram below shows how displacement varies with time as a wave passes through a fixed point. This is more like when a wave approaches a shallow region. Okay, a wave of water approaches a shallow region. The wave has a speed of 12 centimeters per second at R. The wave crosses the boundary PQ where the distance between crests changes from 3 to 1.5, therefore to half. What is the speed of the wave? The speed also changed by half, so the speed will be 6. Frequency will remain constant here, but speed and wavelength will reduce. Speed and wavelength will reduce, but frequency will remain the same. So my answer there is B, 6 centimeters, 6.0 centimeters per second. The diagram below shows a region of diagram below shows a longitudinal wave. Okay, this is more like a sound wave. What letter above represents the wavelength of the wave? Therefore, this is a compression region, and this gap here is a rarefaction. So one wavelength is composed of a rarefaction and a compression, and the answer which suffices here is D. D starts from here and ends just here. So it's only including this gap and this compression there. So my answer there is D. 24. Which expression gives the distance traveled by an echo? Remember, determination of speed of sound using echo method is given by this formula 2D over time, because the echo has to travel to and from, okay, and the time is the total time for traveling to the barrier and bouncing back as an echo to the source. So when you make distance the subject, the answer will come out as D. Okay, the answer will come out as D. Distance is equal to ST over time. 25. How long? Which row shows parts of an electromagnetic spectrum in order of increasing wavelength? My answer is A. Okay, ultraviolet have shorter wavelength, followed by infrared, which have a much longer wavelength, longer than red, then microwaves, okay, which have a much longer wavelength than radio. So you have to have analyzed the electromagnetic spectrum. Answer is A. 26. The diagram below shows a learner standing in front of a plane mirror. This is grade 11 light, topic of light, reflection. So how far from the person is the image? Properties of an image formed by a mirror. they are equidistant from the mirror line. So if the person is standing 2 meters from the mirror, the image will be 2 meters in the mirror. So the distance from the person to the image is 4 meters. 2 plus 2 in the mirror. The answer is D. Number 27, the diagram below shows a converging lens or focal length F. Okay. Where should the object be placed in order to produce an image shown? This is the second focal point. Therefore, this image can only be here if the object is placed on the second focal point on the other side. Okay, so when it's here, then the image will be formed there. Check out those diagrams of what will happen if the image is at D, what will happen if the image is at C, what happens when the image is at infinity. Check out those diagrams, but the answer here is A. 28, the diagram below shows a brass rod and an iron rod beside each other at the bottom of a rectangular coil. Okay, so what happens when a direct current DC passes through the rectangular coil? Of course, the rectangular coil will be magnetized. Okay, because a wire current develops magnetism, develops a magnetic field. But brass is an alloy of copper and zinc. Therefore, both of those metals are not really magnetic, but iron will be magnetized. So my answer there is C, because it will respond to the magnetic field produced by the coil. 29, the diagram below shows a magnet enclosed in a piece of metal. A compass brought near the metal is unaffected by the magnet. Therefore, this piece of metal should be a magnet shield, a magnetic shield which prevents leakage of magnetism. My answer there is iron. Okay, iron is a perfect magnetic shield. 30, when a charge of 10 coulombs flows through a lamp, a current of 2 amps is observed on the ammeter. How much time does the charge take to flow? The formula for charge is Q is equals to IT. Make T the subject. Charge is 10 to 5. The answer is A. The answer here is A. The diagram below shows a circuit with a battery. Resistor 1 and resistor 2 are connected in series while R and 3 are connected in parallel. The potential difference across the resistors are V1, 2, 3 and V4. What is the potential difference supplied by the battery? Therefore, it will be V plus 2 plus the voltage across a parallel section is the same, but current is not the same. The voltage across this one and that one are the same. What is voltage? Energy. The energy is the same, but current is not the same. Current is more in the pathway where there is less resistance when it comes to this kind of connection. So my answer there is C. Number 32. In an experiment, okay, a resistor of 1.5 ohms is required to determine the current, but resistors available are these. Which one of the following arrangements, A, B, C, or D, would give the required resistance? My answer there is C. You have to calculate. Okay, you just have to calculate. Here already, this one is in series to these two. Whatever answer you get here, when you add there, it's going to be more. 2 is already big because this is already counted. Then add what you get from here. 3. The answer is C. When you solve this, you find that this is going to be 3 and this will be 3. Therefore, 3 times 3 over 3 plus 3 will give you 1.5 ohms. 33. Which circuit shows the correct positions of the fuse and switch in the lighting circuit? My answer was C, because L is for live, N is for neutral. The fuse is always placed on the live wire, so is the switch. My answer is C. A household uses an electric fire rated 3 kilowatts and an electric kettle rated 2 kilowatts. The electrical energy costs 5 kwacha per unit. How long did it take the household to accrue a bill of 70 units? We're looking for time here. Okay, so these are the two formulas used in the calculation of cost of electricity. So cost of electricity is equals to units times unit price. These units, this is actually energy. So if the cost is 70, unit price is 50, I mean it's 5, then you divide this 70 by 5, okay, your answer comes out as 14 kilowatts. Okay, this would be the number of units that would have been spent for a bill to reach 70 kwacha. So you get these kilowatts, the units, you plug them in this formula. Energy is equals to power times time. The units are actually energy. So here your energy is actually 14, so you have your 14 there. Power is 5 kilowatts because you have added 2 kilowatts plus 3 kilowatts giving you 5. Then the time comes out as 14 over 5 giving you 2 hours 48 minutes or 2.8 hours. But here there's no 2 hours 48 minutes because rounding off, this is almost 3 hours. So I don't know if it's me who has missed something here, but I failed to solve this one. You can prove it for me. 35. The diagram below shows a circuit diagram of a logic gate. This is an OR gate. An OR gate. A or B will simply give you a 1, or A or B or both when they are closed to give you light here. So my answer there is A. If B is closed, light to be given. So when B is closed, which is a 1, okay, logic level, then you have light. When A is closed, which is a 1, you have light there. When both are closed, you still have light. When both are open, 0, 0, then there's no light. So this is an OR gate. The answer is A. Number 36. The diagram below shows a magnet. And a coil. What? Let me just go back to that. The diagram shows how a magnet and a coil may be used to induce an electric current. Electromagnetic induction right there. So how could the ammeter reading be increased? In other words, how would you increase the current, the induced current? My answer is use a coil with more turns or a longer coil. Okay, that is the answer there. 37. The diagram below shows the transformer that operates a lamp rated 12 volts 3 amps. Okay, that's our primary voltage, secondary current. It's a step-down transformer. A step-down transformer steps up current. So current this side should be very small. So transformer has this much supply and it's 100% efficient. This is important to note because it will mean power in is equal to power out. So when I do my calculations, this is power in, power out. Therefore, I calculate for I, my current comes out as 0.15 ampere, which is C right there. My answer for the 7 is C. For the 7 is C. Coming to the diagram shows one type of radiation passing between the poles of a strong magnet and being detected by this detective there. Sherlock Holmes. Detective Sherlock Holmes. Which type of radiation is being detected? I went for beta particles. Okay, I applied Fleming's left-hand rule. Okay, remember these are electrons and current flows opposite to the electron flow. So as you apply Fleming's left-hand rule, you actually realize that the deflection is upwards. Okay, when in between these the deflection is upwards. So beta particles are the ones there. 39. How many protons, neutrons, and electrons are there in an atom of radium? My answer is D. D is the answer there. Okay, so the last question here in this paper, before I say au revoir, is question 40. A half-life of a radioactive substance is 3 minutes. What fraction of the radioactive substance will remain after 15 minutes? You have to be capable of working with fractions. Fractions are like percentages. So when you do your thingy there, this formula here is used to calculate the number of half-lives. N is the number of half-lives, period over half-life. So number of half-lives are 5. The whole period is 15 minutes, half-life is 3, number of half-lives is 5. Then in ratios, the one here represents a whole, complete substance or mass, complete thing. So in fractions, you multiply this one by this half to the power 5. The answer comes out as D. This marks the end of our paper. Hope it was helpful in any way. Remember to patch up wherever I error or something like that, and I'll see you in the next videos. Have a nice time to study. Have a nice study time. Bye bye for now.